Okay, so for 24, the first thing I need to do is take the square root of both sides. Now when I do this, I have to include plus or minus because that's going to essentially, because whenever you do this, you include plus or minus because 2 squared is going to give you 4, but negative 2 squared is also going to give you 4. So you have to remember plus or minus. So I'm going to have sine of x plus pi halves equals plus or minus the square root of 3 over 2, because I took the square root of 4. Well, what reference angle is sine going to be 1, or square root of 3 over 2? So 1, 2, 3, 1, 2, 3. That top one. So my reference angle is pi thirds. So I want my pi thirds angles. So in the quadrants, those pi thirds angles are going to be pi thirds, 2 pi thirds, 3 pi thirds, nope, 4 pi thirds, and 5 pi thirds. My restriction on this is not for the angle itself, it's for x. So I'm going to set x equal to these, solve, and then I kind of have to consider some options as well. So what I'm going to do is say x plus pi halves is equal to pi thirds, but it's also going to be equal to any coterminal angle to that. So if we look at just the pi thirds angle, that's pi thirds. But I could also do a full rotation and then go there. So that would be 2 pi plus pi thirds because I went a full rotation and then I kept going. I could also do 1, 2, and then a little bit. So 2 pi plus 2 pi plus pi thirds. Those are all going to be coterminal angles. So what I'm going to do to kind of adjust for this is say, well, I want rotations of this. So I want 2 pi or 4 pi or 6 pi, or I could go backwards, so I could subtract 2 pi. So that's where the k comes in. So k is an integer. And that's what that's saying. It's just k has to be an integer. So once I'm here, I'm going to subtract pi halves from both sides. So I'm going to take my pi thirds angle, subtract pi halves from it, and still have the 2 pi k. Now it's going to be easiest if I have everything with a common denominator. So I'm going to go ahead and switch everything to have a common denominator of 6. So then I have 2 pi 6 minus 3 pi 6 plus 12. Yeah. Okay, so let's simplify this, and I get negative pi 6 plus 12 pi 6 times k. Okay, so let's let k be 0. So when k is 0, I get just negative pi 6. If I let k be 1, so I'm just adding 12 pi 6, that gives me 11 pi 6. I could keep going, and I could also subtract more, because there's technically infinite values for that, but my restriction on the problem itself, excuse me, was 0 to 2 pi. That's smaller than 0. And anything bigger, so if we added another 12, so 23 pi sixths, that's bigger than 2 pi. So that is the only one from this angle. Now I have to do that for all of them. So let's look at this 2 pi thirds. So I'm going to kind of come back here, or nope, here, and adjust this. So the difference was this was my pi thirds, but now I want it to be 2 pi thirds. So get a common denominator again. So multiply by 2. And so I get pi 6 plus 12 pi 6 times k. So I get pi 6, and then 13 pi 6. Well, that's too big, so that's my only answer from there. So then we're going to look at the 4 pi thirds. Well, I'm going to rewrite that in terms of something over 6. So that's 8 pi 6. And then I'm just going to rewrite the rest of the commonality. So 3 pi 6 plus 12 pi 6 times k. And I get 5 pi 6. You can't see that very well. So then x is equal to 5 pi 6. And if I add, it's going to get too big. And then, what was the last one? 5 pi thirds, so that's 10 pi 6 minus 3 pi 6 plus 12 pi 6 times k. So that's going to give me 7 pi 6. And again, if I add rotations to that, it would be too big. So those 4 pieces are my answers. Now, the reason why we have to include the full rotations is because if we went with just the angles and then did the subtracting pi halves part, this would have given me originally a negative answer, and that was not within the range. Now, if you're adding and subtracting, you can kind of just do a coterminal angle to this one. But so let's see, like 25 or 23. Let's actually look at 23 real fast. So this one is sine of 2x equals square root 3 over 2. Well, we already know from over here what reference angle that's going to be. That's going to be the pi thirds angle. But it's only where it's positive. So that's here. And here. 2 pi thirds. So I'm probably not gonna have as many answers, possibly. So I'm gonna say, well, 2x is equal to the pi thirds plus full rotations of that. Well, when I divide by 2, I get x is equal to, the way I divide by 2, I think about it in terms of multiplying by 1/2. So this needs to go to both terms. This is a term, and then there's plus, and so then this whole thing's a term. So I have pi 6 plus k times pi. So my answers from here are going to be pi sixths. And if I add, let's turn this into a 6 pi sixths for a common denominator. So 7 pi sixths would also work. So this one's actually giving me 2 answers. And there's not really a way to know before doing it. And so then I have to go back and do the same thing here. So that's why you want to include your full rotations kind of at the beginning, because here we're not really adding a full rotation anymore because we had to adjust for this 2 that was in front. So that's kind of how you set those up. They are brutal, but it's something that you guys need to know how to do, and it is important when you are going forward to be able to do that kind of process. So I promise I'm not trying to torture you. Okay, let me know if you have any more questions.